artificial intelligence, or AI, has evolved from a theoretical concept into a transformative force shaping our world. Its journey spans decades, marked by periods of intense innovation and challenging setbacks. Today, AI is no longer confined to science fiction, but is an integral part of our daily lives. The foundational question that ignited this entire field was posed by the brilliant mathematician Alan Turing in the 1940s. He dared to ask, "Can machines think?" This simple yet profound inquiry laid the groundwork for an entirely new scientific discipline. Turing's vision extended beyond mere computation. He envisioned machines capable of exhibiting intelligent behavior. To assess this, he proposed what became known as the Turing test. This benchmark challenged whether a machine could converse in a way indistinguishable from a human. The Turing test remains a powerful conceptual tool, even as AI capabilities far exceed its original scope. It highlighted the critical need for machines to understand and generate human language. This early philosophical exploration set the stage for the practical development of AI. From these initial thoughts, a complex and fascinating field began to emerge. The quest to build intelligent machines became a driving ambition for scientists and engineers worldwide. This journey has been anything but linear, filled with both triumphs and periods of doubt. The mid-20th century saw the convergence of several brilliant minds who would become the early pioneers of AI. Figures like John McCarthy, Marvin Minsky, and Herbert Simon were instrumental in shaping its initial direction. They believed that human intelligence could be replicated through symbolic manipulation. A pivotal moment arrived in the summer of 1956 at Dartmouth College. This historic conference brought together leading researchers from various disciplines. It was here that the term artificial intelligence was formally coined by John McCarthy. The Dartmouth Conference marked the official birth of AI as a distinct academic field. Attendees shared ambitious goals, believing that significant progress could be made within a decade. They envisioned machines capable of solving complex problems and learning from experience. This period was characterized by optimism and groundbreaking theoretical work. Researchers explored logic-based systems and problem-solving algorithms. They laid the conceptual foundations for many AI techniques still relevant today. The early enthusiasm was palpable, fueled by the belief that intelligence was simply a matter of computation. This foundational era established the core questions and methodologies that would guide AI research for years to come. It was a time of grand ideas and nascent technological possibilities. Despite the initial optimism, the field of AI soon encountered significant hurdles. The AI winter of the 1970s and 80s saw a dramatic slowdown in progress and funding. Early promises proved difficult to fulfill with the limited computational power available. Many AI projects failed to deliver on their ambitious goals, leading to widespread skepticism. Funding dried up, and public interest waned as the perceived limitations of symbolic AI became apparent. This period was a stark reminder of the complexity of intelligence. However, this challenging era also spurred a crucial shift in approach. Researchers began exploring machine learning, a paradigm where computers learn from data rather than being explicitly programmed. This marked a departure from rigid, rule-based systems. Instead of being given specific instructions for every scenario, machines were now designed to identify patterns. They could adapt and improve their performance through exposure to vast amounts of information. This new methodology offered a path forward. The 1990s and 2000s witnessed a powerful resurgence of AI, largely fueled by advancements in neural networks. These computational models, inspired by the human brain, proved remarkably effective at learning complex representations from data. The Internet's explosion also provided an unprecedented wealth of data. This abundance of digital information became the lifeblood for training sophisticated AI models. The combination of improved algorithms, increased computing power, and massive datasets created fertile ground for rapid progress. AI was back, stronger and more capable than ever before. The resurgence of AI, particularly with deep learning, brought a critical need for immense processing power. Training complex neural networks required computations on an unprecedented scale. Traditional CPUs, while powerful, were not ideally suited for this task. Enter graphics processing units, or GPUs. Initially designed to render intricate graphics for video games, GPUs excel at parallel processing. They can perform many calculations simultaneously, making them perfect for the matrix operations central to neural network training. NVIDIA, a leading GPU manufacturer, played a pivotal role in this acceleration. Recognizing the potential beyond gaming, they developed specialized software and hardware for AI workloads. This strategic shift transformed the landscape of AI research. The adoption of GPUs dramatically reduced the time required to train deep learning models. What once took weeks or months on CPUs could now be accomplished in days or hours. This speed allowed researchers to experiment more rapidly and develop far more complex architectures. This revolution in computational power enabled the development of truly groundbreaking deep learning models. It unlocked capabilities that were previously unimaginable, pushing the boundaries of what AI could achieve. The impact was profound and far-reaching. Major AI companies, including Google, Facebook, and OpenAI, heavily leveraged GPUs to power their research and products. This hardware innovation became a cornerstone of modern AI development. It continues to drive the rapid advancements we see today. The capabilities unleashed by neural networks and deep learning have fundamentally transformed AI. Machines can now learn to see, hear, and understand the world in ways previously thought impossible. This has led to breakthroughs across numerous domains. Deep learning models can recognize objects and images, transcribe spoken language, and even translate text between languages with remarkable accuracy. These advancements are a direct result of training on vast datasets using powerful computational resources. AI's permeation into everyday life is now undeniable. We encounter its applications constantly, often without even realizing it. From personalized recommendations on streaming services to the voice assistants in our phones, AI is everywhere. Facial recognition technology, used for security and convenience, is another prominent example of deep learning in action. These systems learn to identify individuals by analyzing complex patterns in their facial features. This technology continues to evolve rapidly. Deep learning stands as the core of modern AI, driving much of its recent success. Its architecture, loosely inspired by the human brain's interconnected neurons, allows for hierarchical feature extraction. This enables models to learn increasingly abstract representations of data. The continuous improvement of deep learning models is a virtuous cycle. As more data becomes available and processing speeds increase, these models become even more sophisticated. This ongoing evolution promises even greater capabilities in the future. The release of ChatGPT by OpenAI in late 2022 marked a watershed moment in the history of AI. Led by CEO Sam Altman, OpenAI introduced a conversational AI that captivated the world. It demonstrated a level of natural language understanding and generation previously unseen by the general public. ChatGPT made advanced AI accessible to the masses, moving it beyond academic labs and into everyday conversations. Millions of users quickly discovered its ability to engage in human-like dialogue, answer complex questions, and perform creative tasks. This widespread adoption highlighted AI's growing maturity. ChatGPT's underlying technology is a testament to years of deep learning research. It is powered by sophisticated neural network architectures known as transformers. These models are trained on massive data sets of text and code, learning the intricate patterns of human language. The development and deployment of such a powerful model also relied heavily on advanced GPUs. These processors provided the computational muscle needed to train models with billions of parameters. Without this hardware, ChatGPT's capabilities would not be possible. At its core, ChatGPT functions as a large language model, or LLM. It can engage in remarkably human-like conversations, generating coherent and contextually relevant responses. Its ability to understand nuance and adapt its style is truly impressive. Beyond conversation, ChatGPT can perform a wide array of tasks, including writing articles, generating code, and even assisting with complex reasoning problems. It demonstrates a versatile intelligence that extends far beyond simple information retrieval. In many ways, ChatGPT represents a significant step towards realizing Alan Turing's dream of machines communicating seamlessly with humans. Its ability to interact naturally has redefined our expectations for AI. It has opened new avenues for human-computer collaboration. Today, AI's applications are widespread and incredibly diverse, touching nearly every sector. In healthcare, AI assists with diagnostics, drug discovery, and personalized treatment plans. Autonomous vehicles are reshaping transportation, promising safer and more efficient travel. AI is also making inroads into creative fields, generating art, music, and literature. In space exploration, AI helps analyze vast cosmic data and guides robotic missions. Its utility spans from the mundane to the truly extraordinary. However, the rapid advancement of AI also brings significant ethical considerations to the forefront. Concerns about privacy are paramount, as AI systems often rely on vast amounts of personal data. The potential for misuse, such as in surveillance or misinformation, requires careful attention. The prospect of job displacement due to automation is another pressing issue. As AI becomes more capable, questions arise about its impact on various industries and the future of work. Society must adapt and prepare for these shifts. Despite these challenges, the future outlook for AI remains largely optimistic. The collaborative potential of human imagination combined with machine intelligence is immense. AI can augment human capabilities, allowing us to solve problems previously deemed intractable. The continued evolution of AI promises to bring even more profound changes to our lives. From scientific breakthroughs to enhancing daily convenience, AI's journey is far from over. It is a testament to human ingenuity and our enduring quest to understand and replicate intelligence.